All right. Hi, everyone. Hope you all had a great lunch. And this is a good post-lunch session to wake you all up on Unity to Unreal Engine transition. And I'm guessing you're all transitioning from Unity to Unreal. It's a good choice. And I'm going to specifically talk a little bit about the mobile development workflow too. But let me just level with all of you. This is not an editor parity kind of a talk. I'm not going to say like, here is the outliner, and here is the hierarchy, and that's not what this talk was all about. So the agenda of today is I'll introduce myself. The meat of my talk is really things I wish was told when I switched to using Unreal Engine. I'll talk about the rendering differences between the two engines, and similar-ish tools where if you're a Unity developer, you will feel kind of right at home when you're using these tools. Some very Unreal's mobile-specific functionalities that will help you create mobile games using Unreal Engine. And finally, we'll talk about ecosystem and next steps. Sounds good? All right. So about me, I'm Arvind Neelakantan. I'm a solutions architect at Epic Games. I've been at Epic for the last 4.5 years. My work has primarily been focused on mobile and optimization. Previously, I worked at Unity for about 4 years, so I kind of know those pains when you're moving from one engine to the other. Now, mobile is very, very important for Unreal Engine. And if you're a Unity developer, and if you're just getting started, I would definitely recommend that you check out this article on the Epic Developer Community Portal called Unreal Engine for Unity Developers. It goes through pretty much what like the editor parity kind of a thing, goes into fairly good detail on all of those things. So it's pretty cool. And when you're switching to Unreal Engine, it's not just me switching from Unity to Unreal Engine. There's been a lot of studios that's been doing that switch too. You can read about all of those studios and why they switched to using Unreal Engine by scanning this QR code. Now let's get into things I wish was told when I switched to using Unreal Engine. So I'm a programmer, so I'm very naturally curious about how things differ between Unity and Unreal Engine under the hood. There are a lot of even philosophical changes behind why some features are the way they are. So let's talk about demonstrating factual differences between the two engines, right? So let's just dive right in. Now let's begin with an empty scene. This is the beginning, right? This is Unity. And I'm going to be creating an empty new scene. There is nothing in the hierarchy. So no lights, no game objects, and when I click play, you see that the hierarchy has nothing in it. It's just got like a debug thing, but it's really got nothing in it, which is what you would expect from an empty application, right? Now this is Unreal Engine Fest. So if I do the same thing in Unreal Engine, I think you already know what's going to happen. I create an empty level, I click on play, but suddenly the outliner is populated with things I did not add at all. And when I was beginning to use Unreal Engine, this confused me a lot. And this is one of the biggest differences between Unity and Unreal Engine, in that Unreal Engine takes care of the boilerplate systems for you by default. Now, what does it mean? As game developers, I'm sure you have made a lot of games. And in the process, you might have noticed that there are a lot of systems that you keep writing over and over again. And you're probably encouraging your team or yourself to then abstract these systems or implement those systems in all the other games that you're going to be making, right? And at Epic Games, we are game makers ourselves, so we know this, and this is why we have abstracted these systems out. Now, what are these systems? Almost all games have the following, right? They have game rules, they have player or players, they have a player camera, there is a player information where you're storing their name, score, and player-specific data. You have a UI, user interface, inputs that are coming from the player, be it a touchscreen or a keyboard, and you also have like a starting position of the player. Now, this is true whether you're making a first-person shooter game or even a match 3 game for that matter. All of this really comes into play. All the things that you saw auto-populated in the outliner is exactly that. Game rules are stored as an object called game mode base. Players are called default pawn. Player camera is managed by player camera manager, and so on and so forth. You get the idea, right? And also, Unreal is naturally multiplayer friendly. So there are a couple of objects called game network manager and game state base that help you with making multiplayer games. Obviously, if you're going to be making your own game, you want to be modifying them. So these properties are set in the project settings. If you go to maps and modes, or even in the world outliner, Unreal Engine provides an existing structure for you to build your games on. Now, if there is one sentence I find very, very dubious, it just works automatically. I don't believe in magic. So I want to know, how does the engine pick these things up? I'm a programmer, so I want to know these things. Now, fortunately, the entire Unreal Engine source code is available for anyone to poke around. So if you look at the world class, which is what is instantiated when you load a level, there is a reference to game mode base class. And as soon as a level is loaded, the game mode base is initialized. And if you go to the game mode base class, you'll notice all the things that you saw in the outliner is all the things that get instantiated over there too. So if you're a Unity developer and you're like, you know what, I want a blank screen, you could actually comment these lines out, and then your level would be completely empty. There'll be nothing in there. But you really don't want to do that, because what you're seeing in action is the extremely robust and tested gameplay framework. Now, this is the backbone of game development in Unreal Engine. The Unreal Engine gameplay framework is this core set of classes and concepts that provides this structure and modular foundation for building gameplay mechanics and experiences. And it's designed to offer developers a very, very robust starting point, and for handling many fundamental tasks that you need when you're making a game. And so my advice is, don't really fight it. It's extraordinarily flexible. So you can use this same structure, whether you're making a multiplayer third-person kind of a game like Lyra. So if you open up the Lyra project, it's also using the same game mode maze and all the other things that's coming under it. Or whether you're making a top-down casual RTS kind of a game like Cropout, which is also available on Fab for you to kind of poke around how that's being set up. Or whether you're making a brawler, or whether you're making a FPS game, whether you're making a dungeon crawler. These are, by the way, new templates that's available in Unreal Engine 5.6. All of that are based on the same gameplay framework over and over and again. And it's not just us making use of it, right? It's every other game. And by the way, all of these games are mobile games. So be it Tower of Fantasy Hota, the Oregon Trail, Ni no Kuni, of course, Fortnite itself, all of them using the same framework. And I'm from India, and from my neck of the woods, there's Raji, and from Asia, there's Final Fantasy and Blue Protocol, all of them using the same framework over and over again. So it's an extraordinarily flexible framework. And all the objects that got added to the outliner, like in Unity 2, are selectable in the level. So you're able to position them wherever you want. So this brings me to the second important conceptual difference between Unity and Unreal. So let's talk about these objects that you see in the level. This is Unity. Any objects that you can see and edit in the scene window is called a game object. So here I'm adding a cube, which is a game object. I'm adding it to the hierarchy, and I can kind of move it around if I want to. So I'm adding a cube. So there you go, cube, blam. Awesome. And all the properties of that cube, such as its mesh or material, are stored as a component. And you can modify these components or add new ones, which I'm sure as Unity developers you might be familiar with it. Now, Unreal has a similar paradigm. All the objects that you see or modify in a level is called an actor, and these actors can then have actor components, which are the properties that define the actor. Like in this case, this is a cube, which is an actor, and that has a static mesh component, which is what makes the actor show the cube like a mesh. And similar to Unity, you can also add new actor components to the actor by clicking on the Add button. There's a lot of preset actor components also. Now, the cool thing in Unreal is everything in Unreal Engine is either an actor or an actor component. And of course, the actor and actor component themselves inherit from the base U object. And you'll see some old friends in this image, right? Like pretty much like the end of a Scooby-Doo episode, if you just kind of like rip off their mask. The entire gameplay framework we spoke about earlier are just actors the entire time. Gasp. And since we have source code access, you can also easily trace the hierarchy of this. And as a side note, you'll notice all this A actor and U actor component, which when the first time I was looking at it, I was like, what the hell is going on? This is an Unreal Engine convention that all actors have a prefix A, and all actor components and objects have the prefix U. So A is for actor, U is for UObject. Now let's talk about the building blocks of any Unity game, which is prefabs. Now creating a prefab in Unity is pretty straightforward. You just create a game object, you drag it from the hierarchy into the project window, and that's about it. Now you can then edit this prefab in the prefab window, add and edit its components, and in Unity, the prefabs are flat and don't really support your traditional object-oriented inheritance in the same way that scripting classes do. Now there is a alternative data-driven approach through the concept of prefab variants, where you can create a child prefab that inherits the properties and structure of the base prefab. But these are more like templates for game objects and not really true classes in the classical programming sense. So now heading back to Unreal Engine, for the most part, the equivalent of prefabs is blueprints. That said, blueprints are more structured and fundamentally class-based. They fully support inheritance, and you can see the same kind of inheritance in action everywhere. So you can see the actor, pawn, player controller, game mode base, the same kind of hierarchy happening everywhere when you create a new blueprint. So for example, if I create a game mode based blueprint, so I'm just going to go blueprint, I'm going to create a game mode base. Let's do that. Let me just call it something BP underscore my game mode, and you'll notice that in the details panel, all the properties that you see are what the game mode based class is exposing to your editor, which is what you'd expect from inheritance, right? And you can of course add actor components to the blueprints, just as you would expect. So here I'm adding a static mesh component and I'm adding a cube mesh to its static mesh property. But the real superpower of blueprints is that it comes with visual scripting. So while adding custom components in Unity requires you to have C# classes which extends mono behaviors, with blueprints you can write complex behaviors just through visual scripting. And blueprint visual scriptings are incredibly powerful in that you're able to ship entire games just using this visual scripting mode without writing a single line of code in C++. So Cropout sample project, by the way, is a really good example of such a project, which is a production-ready project made just using blueprints. So this also means, as an artist or a technical artist, you're now able to contribute more to the game development process rather than having to wait for a programmer to write code to help you with some kind of functionality. Now blueprints are amazing, and they have a lot of features. So here are some top 5 features that I thought was worth mentioning, especially when I was switching from using Unity to Unreal Engine. Number 1, like I mentioned, all blueprint nodes come with corresponding C++ code. So I don't like black boxes. So anytime I want to know how things work, you can double click on any blueprint node and it'll just open up the Visual Studio to show you what that node is doing. And you can kind of poke around to see like how was it written. Number 4, you can add breakpoints to your blueprints just like you would when you're debugging C++ classes or C# classes in Unity. So here I'm adding a breakpoint to a branch node, and when I reach that node, it breakpointed there. You can also see the call stack of that breakpoint, which is super useful when you're working with any kind of programming language, so you kind of know where that node was being called from. Blueprints also help you visualize logic flows when the game is running. So this is the Cropout game. So whenever I touch the screen to move a villager, the corresponding code gets executed, and I can see that logic flowing in the editor also, which is cool. Number 3 is Unreal Engine comes with a diff tool for blueprints. So if you're a programmer or if you're working with a version control system, you can connect the editor to the version control system and you can diff blueprints to see what were the changes made between one version and the other, which is amazing and is exactly like what you would do when you are writing C# or C++ code. Number 2, well, you always knew that you can copy paste blueprints into this blueprint nodes into the same editor, right? And I always knew that. But you can also copy blueprints to a notepad. So here I'm copying blueprints to a notepad, like a text-based editor, and you can paste that text copied into Unreal Editor, or even use something like this, the ueblueprint.com, I think, website, which has nothing to do with Unreal Engine, by the way, but they're able to read the text file and also recreate the blueprints. And this is a much better way for you to share your blueprints rather than just sending screenshots. And so this is just amazing. This blew my mind when I first knew about it. Number one, this is my most favorite. When you're making a mobile game, you are typically dependent on DLCs to push your content, to push your assets. Blueprints are treated like content assets. So in the context of Unity, let's take asset bundles, which are just compressed archive files which just contains your game assets. And that's the way you distribute your assets for on-demand loading, or for reducing your install size, or for enabling your DLCs. But asset bundles can't contain assemblies, so you can't use them to distribute new C# classes or even change existing C# classes. On the other hand, Blueprint scripts compile down to bytecode, so you can package them to pack files. So this can be downloaded by the game after the initial binary installation. So here I'm creating a pack file which includes a blueprint, so a blueprint script. So here is a data asset label that I've used for creating a pack file, so that's a chunk. And in here I can then say, add a priority, I can add a chunk ID, and then also at the bottom you have explicit blueprints, which I can then specify that, hey, these are like blueprints I want to pack along with my DLC, which is amazing. So here are some things to note regarding blueprints as content. So blueprints can be added as DLCs, which is great. When you load your initial binary in your mobile device, the C++ code is loaded in its entirety in its game during the game load itself. Whereas blueprints, on the other hand, are only loaded as required. So it's very important to keep your blueprints as modular as possible, because blueprints referencing other blueprints will also then load. And this can, of course, then impact your memory and your load times, which is why if you're working with blueprints, definitely always keep the reference viewer open. So the blueprints can then let you visualize whether it's referencing other blueprints within your game. Now, if you want to know more about how to chunk, how to use DLCs within Unreal Engine, check out this article on chunking. It kind of tells you like how to separate out your blueprints and your assets into chunks, and also shows you how to host it on a server so you can download it after the game has been loaded. Now, an immediate question I get asked about blueprints is performance. Now, my advice typically is you should not just use hunches to define the architecture for just a fewer CPU cycles. Now, when benchmarking, you need to be aware that blueprints overhead differ based on where you're benchmarking your blueprints. So in this graph, you can see that the play in the editor or Pi blueprints perform very badly. But the same blueprint on a shipping build performs much better. That said, blueprints do have a little bit of overhead if you're writing as compared to like when you're writing in C++. But that said, a project typically should not just be an either-or. It's not just a blueprint project or a C++ project. It should be a combination of both. So you should weigh in both developer efficiency and your hardware performance when you're making a decision whether you're going to be using blueprints or C++. And sometimes the blueprints just have a very tiny overhead, which probably even doesn't matter. So now let's take a look at C++ in Unreal Engine, especially like Unreal Engine C++, right? Now, Unreal C++ and Unity C# actually have a lot in common. To begin with, the most common thing that people prefer C# for is the garbage collector. And in Unreal C++, it also has a garbage collector. So remember that UObject I talked about earlier? Anything that is a UObject, which is pretty much everything in Unreal Engine, is managed by the garbage collector. So the garbage collector uses a mark and sweep algorithm to identify and reclaim memory. So it works very much like what you would expect for C#. But remember, I told you I don't like when I just say like things work automatically and like, just trust me, garbage collector works. Don't trust me. Let's see it in action, right? So let me just first create a C++ class. So I'm just going to go to tools. I'll just create a C++ class, and you'll notice that the classes that you're seeing that you can inherit from is also the same kind of hierarchy that you saw earlier for blueprints also. So the same UObject actor component inheritance is also available here. Now, for the sake of this demonstration, I created a couple of classes in C++. And to edit the classes, I'll have to just open it up in Visual Studio. So let's take a look at those classes. So I created a class called myGarbageCollectable_object class, which is marked as a U class. And it just extends a U object, and it really doesn't do much. It's just an object file, like a U object class. Now, I also then created a myGarbageCollectionActor, which is also a U class, and it extends an actor class. Now, this can then be added to my scene because it's an actor. Now, you'll notice that I have this macro called U property added, which means that the garbage or GC or garbage collection will mark it for garbage collection, and it's very important to mark it that way. And in my myGarbageCollectionActor implementation, I have this new object function. Now, in Unreal Engine, U object should be created with the new object function instead of just creating this using the C++ new method. So this function not only allocates memory for the new object, but also registers it for your Unreal Engine's object manager system, making it eligible for garbage collection. So here I'm setting up the garbage collection one. I am creating a new object using the new object paradigm, and then in another function, if I just scroll a little bit down, you'll notice that I'm setting it up as null. So in the cleanup garbage collection demo, I'm just setting it as a null pointer. Now remember, I am not doing the garbage collection. I'm just setting it as null. Now let's go back to the editor, and I'm going to create a new blueprint class which extends the new actor I created, the myGarbageCollectionActor. So in all classes, I'm just going to search for this myGarbageCollectionActor. So I'll create that, and I'll create a new blueprint. Now you'll notice I'm just creating like BP_GC, say example. I'm going to open it up, and I will go to my event graph, and you'll notice that the two functions that I created in C++, I had marked it as a U function, and you'll notice it on the left hand side. Any function that's marked as a U function with blueprint callable is also available for me as a node in blueprints, in blueprint visual scripting. So I'm calling the setup garbage collection node or the function, having a delay of 10 seconds, and then I'm calling up cleanup garbage collection. And then just because I want to visualize this actor, I'm just going to add a static mesh. Let me just add a static mesh, some random stuff. I like to scroll quite a bit. So I'm scrolling and I'm adding that. That's my actor. Let me save, go back to my new map, and I will just drag this new actor. So what will happen now is this should then be ready for garbage collection. So what will happen is if I compile this, because the actor is on the stage, the two nodes of creating a new object and cleaning up the object where it's just setting up to null. I'm not really cleaning it up. I'm just setting that object to null should then be instantiated, or should be called rather. Now before I show you the demo, be aware that the garbage collection runs in a set interval. So it's a mark and sweep algorithm. So in the project settings, by default the garbage collection happens at every 61.09 seconds. If you like your garbage collection to happen more frequently, you can always change that timing too. So in my case, it happens almost like a little over a minute. So in Unreal Engine source code, memory allocations are usually tagged by a low-level memory tag or an LLM tag. And since Unreal 5.4 for Android and with 5.5 for iOS, we've added support for what is called memory insights. Now it's part of your typical Unreal Insights, and it's a newer tool that can display memory based on LLM tags. It also captures a call stack with each memory allocation and deallocation, allowing you to see where exactly allocations or deallocations are happening. So in this case, this is on the left hand side is my Unreal deployed on my Android device, and the right hand side I'm having memory insights. What I really care about is this U object. I know it's very tiny, but U object is what I really care about. Now at about the 60th second, and I'll just pause over here, you'll notice that there is a dip at the very bottom that you can see right there, which is where my garbage collection acted. So you can see right there, if I just scroll, or if I just see where the timing of that garbage collection happened, it's just over a minute, like 1 second after a minute, which is what my mark and sweep algorithm was set to, right? So at exactly 61 seconds, garbage collection happened on my uObject class. So with memory insights, garbage collection happens. So hey, I'm not lying. And second, you were also able to pinpoint exactly what uObjects are being garbage collected, and if there are memory leaks or if there's things that are not marked correctly, then you're able to identify them and fix those memory leaks. And in order to make sure that the GC tracks your pointers, make sure that they are marked correctly, because if they're not marked correctly, then they would not be garbage collected. So the most common thing to use is this macro called uProperty, and there's also other properties like your the tWeak object pointer or tSoft object pointer, depending on whether you want a soft reference or a weak reference. Now, to know more about how to use memory insights, check out this Epic developer community post I wrote. It goes into a great lot of detail on how to set up memory insights and how you can use them. All right. Now, let's take a quick look at the rendering differences between Unity and Unreal Engine. Now, out of the box, Unity provides two rendering pipelines. There is the Universal Rendering Pipeline, or URP, which is meant to perform well on all devices, and you have HDRP, or High Definition Render Pipeline, which is meant to be performant on higher-end devices like PC and consoles. Now, unfortunately, the choice between the two is permanent during game development in Unity. So if you choose HDRP for PC game and later want to switch to URP for mobile development, it is at least not straightforward, to say the least. Unreal, on the other hand, has a unified rendering pipeline. So it's meant to perform cross-platforms from the very start. So the editor also provides some excellent tools that allow you to scale the assets and also play with your render quality based on which platform you're going to be deploying your game to. And the unified render pipeline pretty much works the same from like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across all platforms, but it kind of varies its performance based on where you're going to be deploying it to. The Unreal Rendering Engine really scales really well too. So in terms of visual parity, here is an example from this game called Tower of Fantasy Horta. And you'll see the visual differences between mobile and PC is very, very small. The video, in fact, was created by this YouTuber called Dear Impact. Left-hand side is mobile, right-hand side is PC. And the devices getting better and better means that the visual parity is only getting better and better. And here is another example captured from directly a mobile device from Netmarble's King Arthur. Can you have the sound, please, on this one? I'll just pause right there, but it's a long video. But you can see the visual quality that Unreal is able to provide, and this is on a mobile device. And more screenshots. This is again from the same game, and another game. So I think this is from Kuro Games' Wuthering Waves, which has been making waves in the gaming community. And it's also cross-platform on mobile, and just looks amazing. Now, this has been the case since even UE 4.27, but with UE 5.5, we have made a number of improvements in the engine on how it handles mobile rendering. So let's walk through a couple of those improvements really quickly. The first important thing is GPU scene. Now, what is GPU scene and why do you need it really? So in short, GPU scene is just this collection of GPU buffers that just holds information about all the objects in your scene. So it enables this auto-instancing or dynamic instancing where you are able to merge several draw calls into the same rendering state into a single draw call. And GPU scene exists and is used in Unreal Engine for several years on PC and console, but only recently has it been enabled for even mobile devices. Now, enabling GPU scene allows you to allow some really nice GPU-driven techniques. One of them is per instance culling on GPU for instance static mesh. One more feature that was added recently is the ability to select your LODs for each instance on GPU. So this is also enabled by default when GPU scene is enabled for mobile devices. And if you're into making open world games, it also works on mobile using GPU culling, which is also enabled through GPU scene. So all these landscape tiles that you're seeing for open world games are just basically very compact instances. So they can be easily culled on the GPU in a similar way where we do per instance culling for instance static mesh 2, which I showed you earlier. Then there is this HITCH, right, like the runtime PSO pre-caching. Now, so in the top left corner, we have this performance graph that shows you this basic performance information like frame time, game, and render thread. And once your camera moves, so new objects then get on your screen, you can experience this very bad frame drops. I'm sure a lot of folks have seen this, right? By the way, through using Memory Insights and Unreal Insights, there's been a number of reasons that can happen, but we know through Memory Insights and Unreal Insights that this was caused by a shader compilation hitch, and the more modern name for it is called PSO compilation hitch. Now, why is this happening? Because whenever the engine renders some object with shaders for the very first time, it needs to create and compile those shaders for some intermediate format into it before it can take its final GPU microcore format. And this compilation happens in the driver and can take a significant amount of time depending on the CPU power of your mobile device and of course the complexity of the shader also. With 5.4 and 5.5, in fact, we now have solved this, and it's enabled by default, and it's called the PSO pre-caching method. And what this does is, when a game loads a level, for each loaded static mesh or a skeletal mesh or landscape or particle or any other components, we are able to then first look at all the materials that's been used by these components, and we are going to collect all the possible PSOs that those components can have. And the idea is, by the time we need to render an object which has some shader in it, it will already be compiled, and this is enabled by default. And you also have some fallback, because if it's not 100%, it doesn't work all the time sometimes. So you want to make sure that there's also a fallback available if you want to. Now next, the number one question I get asked all the time is Nanite and Lumen on mobile devices. Now it works through this desktop renderer on mobile, and it's very much experimental, and it works on recent mobile devices, which can in fact enable desktop deferred renderer. Do not use it in production yet, but it's coming. Now let's look at the similar-ish tools between Unreal and Unity, and this is going to be very short. So in Unreal and Unity, so in the physics engine that we use in Unreal is Chaos, in Unity is PhysX. UI and input is handled by common UI and enhanced input. In Unity it's UI system and input system, and they both sort of operate in a similar fashion. When you're doing animation or in-game camera cuts, then you can use Sequencer for Unreal and Timeline and Unity. When it comes to writing shaders, you can use the material editor for visual material editing, and then you have shader graph in Unity. And for particles, we have Niagara, and in Unity we have particle systems. And all of this, when I was playing around, they kind of act similar in terms of like just the user interface. So you should feel right at home when you're switching from Unity to Unreal Engine to use these systems. Now let's look at some very mobile specific functionalities that exist within Unreal Engine itself. Now one of the core concepts or the core philosophies that Unreal Engine believes is you shouldn't be branching your entire game in order to make a mobile game. Whether you're making a PC game, when you're making a PC game or a console game or a mobile game for the same game, it should be in the same code base. And as a mobile game developer or as a mobile game studio, typically there are about 4 quadrants or 4 aspects of your editor that you would like to be working with. First off, you'll be looking at developer efficiency. So whether what's your editor workflows looking like, how easily are you able to deploy your game, your CI/CD pipelines, how easily are you able to test your game, and how easily are you able to collaborate with your team. The second quadrant that you're looking at is mobile memory and optimization. So how well are you able to optimize your asset? You want to be looking at memory insights to track leakages. and also a build and asset delivery system like your DLCs. And your third quadrant is your visual fidelity. You just want the engine to do most of the heavy lifting over here. We want to make sure that the engine just performs well, it looks amazing just out of the box. And you want third-party support. So when you're making a mobile game, you want to have ads, in-app purchases, notifications, integration with third-party libraries, and so on. So let's look at how Unreal Engine performs when you're looking at these 4 quadrants really quickly. The first quadrant is developer efficiency. Now, when you're working on mobile device with mobile games, you want to often be deploying to mobile devices. And if you're going to be supporting a lot of mobile devices, it's going to be painful to have physical devices available. So with 5.5, we now have Android emulator support. So this is the official emulator provided by Android Studio, and you're able to connect directly from the engine to the mobile device. So if I go under platforms, if I run the emulator, I can go under platforms, and that emulator will now show up under my platforms, and able to just connect directly from the editor into my emulator. We are also working on launching multiple emulators at the same time. So you can have 5 or 6 emulators running at the same time, and you can deploy to all of those emulators. Now, emulators are amazing because you're able to test your game on these emulators because they're very, very close to the real hardware itself. If you're a programmer, you don't want to keep deploying your entire game and cooking all of your assets. If you're just writing C++ code, we now have this option in project settings called Don't Bundle Libraries into APK. If you switch it on, it'll only bundle your C++ code and not bother sending or cooking your assets every time. Now then I can also then hear your artists whisper now, which is what about artist efficiency? Now Zen Streaming is your friend, and it's been available since 5.5. It's officially production ready at least since 5.5. Now this chart is fairly dense, so let me just walk you through it very quickly. Now on the top blue barrels that you see, the first one is the Unreal Editor. So anytime you're loading your game into Unreal Editor, all the assets that are required for that editor is cooked, and it's stored as a cooked output data into your local machine or into your DDC cache. And every time you're compiling your game to be pushed to mobile, there is a staging stage where you have the same build, cook, and run happening. A new set of cache is being created, and then when you're deploying, another new set of cache for your assets are being created. So it's very time consuming if you're going to be deploying and iterating your game. What Zen Streaming does, on the other hand, is it just bypasses the stage and deploy part when you're testing your game. It directly streams the assets that has already been cooked for your editor and dumps it into streams it into your mobile device. And this means that if you just want to, as a technical artist, as an environment artist, or a level designer, you just want to see your game working on a mobile device, you don't have to do the entire staging and deployment cooking for the mobile device. You can just stream it through Zen Streaming process. So Zen Streaming, let's see it in action, right? So this is crop out game, and I am streaming this game, and you'll notice that on the top left corner there is a Zen Streaming happening, and this means that assets are not in fact stored in my mobile device. The assets are being streamed from my PC, which is my development PC, into my mobile device. So it greatly improves your artist iteration time. Now setting up Zen Streaming is ridiculously easy. You just have to have these 2 checkboxes. So there's you need to enable Zen Server in your project settings, and in your default engine.ini file, just add these 3 lines where you're just saying zen.auto launch, limit process lifetime to false, allow remote network service to be true, and you're done. So when you then deploy your games to your mobile device, you're just streaming your assets and not really cooking your assets. Now be aware that don't use this for production, of course. Use it purely for testing purposes. Now the next quadrant that you're looking at is mobile memory and optimization. which is asset optimization, device profiles, memory insights. Now, I have 10 more minutes left, but fortunately, I went into spectacular detail on how to prepare your assets for cross-platform applications. So you don't want to be compromising on visual fidelity when you're deploying for PC and console, but you still want to be having the same kind of visual fidelity, but with better performance on a mobile device, and how to set those assets up. I go into detail at my previous talk at UEFest Seattle. Do check it out. There is also this, if you are a non-video person, if you like to read the same thing in text format, I also wrote an ADC article called Memory Optimization, Mobile Memory and Optimization. You can check that out too. Then the next quadrant that we're looking at is visual fidelity, rendering, and performance. And I think we went into great detail about it earlier, so I don't want to iterate it. But you know that Unreal Engine does really well on mobile devices in terms of visual fidelity. And the fourth and final quadrant is the third-party support, which is also adds in-app purchases, notifications, and so on. Now, I would say this is probably a less evangelized part of Unreal Engine. So let's look at that. So let's look at ads. Ads, in fact, AdMob specifically has native integration within Unreal Engine. So there are, in fact, in Blueprints, there is a show ad banner node, there is a hide ad banner node, and so on. So if you want to be showing ads in your game, this just works automatically. Similarly, for in-app purchases, there are also in-app purchase nodes which are wrappers for both Android and iOS. So you have, let's say, the read in-app purchase information or the start an in-app purchase node in Blueprints. It just is already there. And similarly, for notifications, you have the schedule local notification or other notification related blueprints that allow you to show notifications. And finally, if you have like an SDK or libraries that don't have Unreal Engine support, check out apigear.io. Now, this is an open source tool maintained by Epic Games. So you can then define what the APIs look like in whatever third-party application exists. And API Gear will then generate Unreal native SDKs for you, and you define your business logic after it's generated that plugin for you, which means that you don't have to be worrying about SDK support for third party. It is you generate the plugin and you just fill in the business logic fairly easily. So with that, when you look at the four quadrants, I think Unreal does pretty well, whether it be developer efficiency, mobile memory and optimization, visual fidelity, and of course third-party support. And so before I conclude, I hope now you understand why you should be using the gameplay framework and why Unreal doesn't start with a blank level. I also hope that you understand how Unreal's rendering engine scales across platforms and especially useful for mobile games. And the idea really is to help you make mobile games simple by letting you build on top of a very, very robust system, which is the gameplay framework. And also note that along with the gameplay framework, there are also other frameworks that help you make games, which let you concentrate on actually making the game rather than just creating these boilerplates, like the gameplay ability system or the Mass AI, which allows you to create AI systems, not like your Gen AI, but your NPCs that can kind of walk around, which also ease your entire game development process. And with Epic Games, we don't just provide the tools, right? We also help you build with an ecosystem of tools which helps developers throughout the game development cycle. So be it tools like Unreal Engine, and then you also are able to get content from Fab, or you're able to then leverage services like your multiplayer services through Epic Online Services. You're able to distribute your game through the Epic Game Store and even through Fortnite if you're creating from UEFN, and also reach out to our communities, which is amazing, on both ArtStation for artists and through the Epic developer community for anyone else. So if you want to know more about how to get started with Unreal Engine and mobile game development, check out this link again. It's awesome, helps you with a lot of these initial hand-holding when you're creating a mobile game. And while you're in the process of creating this kind of mobile game, do join the Epic for Indies community. It's awesome. There's a lot of people making mobile games and games in general using Unreal Engine. All of them have been put together in a nice Discord channel. There's a lot of chatter about how to use Unreal Engine, and generally it's a nice community for you to ask questions. And once you make your game, can then publish it on the Epic Game Store, which is now available on iOS and Android in certain countries, or iOS in certain countries, and for Android globally. So you can then start making games a business for you, which is awesome. So with that, that's my talk. So thank you so much. I hope that helped you with transitioning from Unity to Unreal Engine. Thank you.